The Golden Gate once defined American engineering, a symbol of power, progress, and pride. But this new bridge in China, it doesn't just outshine it, it humiliates it, brutally, twice as tall, built in a canyon where bridges weren't supposed to exist. The Huajiang Canyon Bridge is a ruthless display of ambition, and it just made one of America's greatest landmarks look humbled. In 1937, when the Golden Gate Bridge opened to the world, it wasn't just a feat of engineering, it was a global statement. Stretching across San Francisco Bay in brilliant, international orange, it was the tallest and longest suspension bridge of its time. It stood 227 meters above the water, with a main span of 1,280 meters. For decades, it defined American innovation, grit, and the ambition to push boundaries. Tourists flocked to see it. Engineers studied it. Hollywood featured it in dozens of films. It became a national symbol, one that whispered, "This is what a superpower builds." But in 2025, that whisper is being drowned out. And not by another American project. It's being silenced by the Huajiang Canyon Bridge, China's answer to every iconic structure that came before it. Rising from the cliffs of Guizhou province, this bridge isn't just taller, it's on another level entirely. Its deck will hover 625 meters above the canyon floor, nearly twice the height of the Golden Gate, and about 60 meters higher than China's current world record holder, the Beipanjiang Bridge. It spans 2,890 meters in total length, with a main suspension span of 1,420 meters, edging out even some of the most famous bridges in the world. But raw numbers only tell part of the story. While the Golden Gate was constructed over relatively calm waters, Huajiang had to be built in one of the most geologically unstable, weather-tormented landscapes in Asia. The cliffs are steep, the rock is fractured, and the winds can whip through the canyon with no warning. The region suffers from sudden temperature swings, torrential rain, and frequent landslides. In short, it's a place where bridges aren't supposed to exist. And yet, China decided to build the world's tallest bridge here, not in a city, not over a peaceful bay, but in a jagged gorge where logistics alone should have killed the idea. That choice wasn't a coincidence. It was a message. This is a demonstration of capability, a global flex, a way to say, we can do what you won't even attempt. Compared to Huajiang, the Golden Gate is a museum piece. Beautiful, yes, but frozen in time. Huajiang is alive, aggressive, and still under construction. And what comes next only widens the gap between them. The Golden Gate Bridge was built in 7 years. Its biggest challenge? Dealing with bay winds and underwater anchoring. It was a masterpiece for the 20th century. But Huajiang, it's breaking records, brutally. The Huajiang Canyon Bridge is being built in a region that looks more like a lost world than a construction site. The cliffs are sharp, the rock is fractured. The canyon is so deep, it's nearly impossible to measure without high-precision drones. And yet, China chose to build the world's tallest bridge right here, like planting a flag on the moon. At 625 meters, its height dwarfs not only the Golden Gate, but almost every other structure built across a gorge. Think about that. That's like stacking 2 Eiffel Towers on top of each other and still having room left. Its main span of 1,420 meters makes it one of the longest suspension bridges on Earth, outstretching even Japan's Akashi Kaikyo Bridge, and rivaling icons like the Verrazzano Narrows in New York. But the real brutality lies in the execution. To build something of this scale in such an environment, the team had to deploy one of the most advanced aerial cable crane systems in the world, a high-tech system powered by the Beidou satellite network, China's rival to GPS, and integrated with IoT tracking and over 30 HD cameras to guide each massive steel truss into place with millimeter precision. These trusses, they're monsters. Each one weighs tens of thousands of kilos, over 21,000 tons of truss segments in total. And yet they're being positioned so precisely that they fit together like Lego pieces. And here's where it gets even more brutal. What once required 20 crew members on site now only needs 2 operators in a digital control center. They've turned one of the world's most dangerous engineering zones into a remote-controlled assembly line. The 2 main towers that support the bridge are also a lesson in engineering aggression. The North Tower stands 262 meters tall, anchored into deeply weathered rock with hidden water veins and fault lines. Any mistake could lead to disaster, but the engineers reinforced it using high-strength earthquake-resistant steel, capable of flexing under intense pressure without compromising the structure. Why go through all of this? Why pick a canyon that's basically screaming, "Don't build here"? Because yet again, it's about sending nations a message. We can build where you wouldn't dare, at a scale you can't match, with precision you can't rival. This is a statement, and the world is watching. Building tall is hard. Building tall on the edge of a fractured canyon with active landslides, unpredictable windstorms, and unstable rock formations? That's a nightmare. But that's exactly what Huajiang's engineers faced and conquered. Guizhou Province, where the bridge is located, is one of the most rugged regions in all of China. Over 92% of its land is mountainous or plateau terrain, and until recently, much of the area was considered geographically isolated. Roads were scarce. Many villages relied on century-old rope bridges and footpaths. Some communities couldn't be reached by vehicle at all. This wasn't just about building across a gap. It was about punching a high-speed corridor through terrain that actively tries to destroy infrastructure. The foundation work alone was a masterclass in risk mitigation. Take the North Tower, for example. It had to be anchored into weathered rock full of hidden cracks and water channels. These kinds of underground voids can shift, swell, or erode, creating catastrophic instability. To deal with this, engineers used deep pile foundations, reinforced with earthquake-resistant steel bars, designed to hold firm even if the surrounding rock gives way. Then there's the climate. Guizhou's weather is nothing short of volatile. During a single day, temperatures can swing dramatically. Storms form fast in the valleys and sweep through with violent winds. Exactly the kind of conditions that make lifting massive steel components by crane extremely dangerous. So what did they do? They installed a solar-powered wind monitoring system on site. Not like the weather station in your kitchen window. It was a smart system that sent real-time wind data directly to the digital command center. If gusts exceeded safe limits, operations would halt instantly. In a place where a single mistake could send tons of steel crashing into the canyon, this wasn't just a safety measure, it was survival. And then came the logistics. Getting materials to the site was a challenge in itself. Traditional trucking routes didn't work here. The terrain was too steep, too unstable, and in many places, there were no roads at all, so they benefit from modular assembly. Components were prefabricated off-site in smaller, more manageable sections, then hauled in and assembled on location with robotic precision. This dramatically reduced environmental disruption, protecting the fragile ecosystem around the canyon, while making the project scalable and fast. All of this, while maintaining millimeter-level accuracy, high worker safety, and a construction timeline that's still on track for completion in late 2025. And to be clear, none of this was easy. The fact that this bridge even exists is an insult to the word impossible. While China breaks records, the United States breaks bridges. That's not hyperbole, it's a harsh truth. In March 2024, the Francis Scott Key Bridge in Baltimore collapsed, killing multiple workers and halting a major shipping route overnight. In 2007, the I-35W Mississippi River Bridge in Minneapolis failed during a rush hour, sending cars plunging into the water and killing 13 people. These aren't isolated incidents. According to the American Society of Civil Engineers, over 45,000 bridges in the U.S. are rated structurally deficient. That's more than 1 in every 11. And while these aging structures creak and crumble, the budget for major infrastructure projects remains tied up in red tape, political deadlock, and endless environmental review delays. The result? Projects take decades just to get off the ground. Meanwhile, in China, the Huajiang Canyon Bridge, a structure that should have been considered too extreme to even attempt, is nearing completion in just 4 years, and it's not a fluke. China now dominates the leaderboard of world-class megaprojects. Of the top 100 tallest bridges globally, over 90 are in China. The country has redefined what's possible in civil engineering, not just through scale, but speed and precision. And here's the sting. The Huajiang Bridge was inspired by the Golden Gate, Its towering design even borrows Art Deco elements as a visual tribute. But the homage ends there. Everything else about it feels like a challenge. We saw your best, it seems to say. Now here's ours. While the Golden Gate continues to be maintained as a historic treasure, it no longer represents the cutting edge. It was built for the era of rivets and ironworkers. Huajiang was built for the satellite age, an automated, data-driven, remotely managed marvel of the 21st century. In the US, infrastructure spending is often reactive, a patchwork of fixes after a problem surfaces. In China, it's strategic. Bridges aren't just solutions. They're long-term investments in trade, tourism, and national image. The Huajiang Bridge will slash travel time across a previously isolated canyon from 70 minutes to just over 1 minute. It'll connect rural communities, drive economic growth, and link into China's sprawling G56 expressway, tightening supply chains and boosting exports. In contrast, the US still debates whether to replace 60-year-old overpasses. This isn't just about concrete and steel. It's about ambition. It's about momentum. And right now, America is falling behind, not just in bridge height, but in vision. The Huajiang Canyon Bridge clearly exposes that gap. The Huajiang Canyon Bridge was never just about statistics. It was about rewriting China's future, one span at a time. Located in Guizhou Province, one of China's least accessible and most underdeveloped regions, Huajiang serves a purpose far bigger than connecting two cliffs. It connects entire economies, isolated communities, and geopolitical trade routes. By integrating into the G56 Hangzhou-Ruili Expressway, a mega highway stretching from China's booming eastern coast to the Myanmar border, it tightens China's grip on inland trade while linking the country directly to Southeast Asia, a move that not only improves domestic logistics, but strengthens regional dominance in supply chains. But it doesn't stop at freight. Guizhou is home to stunning natural landmarks like the Huangguoshu Waterfall and the Guangling Fossil Geopark. For years, these sites remained out of reach for most tourists. With Huajiang in place, tourism is about to explode. Plans are already underway to install glass walkways, extreme sports platforms, and even stargazing decks on the bridge towers themselves. Think about that. The world's tallest bridge, doubling as a tourist destination. Economically, the Huajiang Bridge is expected to drive growth in Guizhou by unlocking access to education, healthcare, and investment for previously isolated populations. The ripple effect? Increased land value, new job creation, and cross-provincial development. Politically, it demonstrates the government's ability to deliver high-impact projects in record time, something Western nations increasingly struggle with. And globally, it's part of a much bigger picture, China's race to become the leader in next-generation infrastructure. You see, Huajiang is part of a pattern, a consistent stream of jaw-dropping projects that challenge the dominance of Western engineering. The question is, no longer can China do it. It's how much further are they willing to go? Because if Huajiang is their benchmark, the next project might make this one look small.